A horizontal tangent comes when our derivative is 0, so dy dx. For parametric equations, that's dy d theta over dx d theta, since we've got our functions here in terms of theta. So we just take some derivatives. Dy d theta, that's going to be sine of theta. And cosine, or sorry, dx d theta, that's just going to be 1 minus the cosine of theta. And we'd like this to equal 0, meaning we would like sine of theta to equal 0. Well, notice that when sine of theta is equal to 0, that means theta is equal to some multiple of pi. Okay. Also notice, however, that at every even multiple of pi, cosine of theta would then be 1, and then we'd be dividing by 0. So we need to find out what's going to happen there at those even multiples of pi. So what we're going to do is, actually we have to look at the limit as theta approaches that even pi. So we're going to go just to 0 because that's, of course, an even multiple of pi. And it's actually where everything else is, it's 0 and 2 pi and all that. So we look at theta approaching 0 of sine of theta over 1 minus cosine of theta. Of course, this is 0 over 0, so we can do L'Hopital's rule. So we do derivative of the top over derivative of the bottom is going to be sine. And of course, this is not equal to 0, which means that we do not have a horizontal tangent there. So we don't actually have a horizontal tangent at our even multiples of pi. So actually it's going to be when theta is an odd multiple of pi. We'll say 2k plus 1, that's an odd number, times pi. And then of course our coordinates then, we have our x coordinate is just, well, 2k plus 1 pi. Sine of each of those is 0, so we can ignore that. And then cosine of every odd pi is -1. So 1 minus -1 is 2. And so these are the coordinates of all the points where we have a horizontal tangent.